Hello, my little mathematicians. Today we're going to be doing our study guide reviewing fractions, all operations, adding, subtracting, multiplying, and dividing, which means you know all of this. So please feel free to try it, pause the video, try it, and then unpause it and come back and join us at any point. Okay, so the first thing is that when you're adding and subtracting, you first need to get a common what? That's right, denominator. Okay, only when you're adding and subtracting do you do that though. And if you get stumped on how to find a common denominator, remember you can always think of it as you're trying to find the LCM. Okay, you can only reduce by cross canceling when you are multiplying fractions. Okay, that's the only time that you can reduce with cross canceling. And then keep, change, flip is only when you are, yes, dividing fractions. Okay, and what that means, what it stands for, is that you keep the first fraction the same, you change the division to multiplication, and you flip only the second fraction. Okay, let's go ahead and get started on these. Remember, you know how to do this, so try them yourself first, and then come back and unpause the video, and let's see how you did. This is adding, so I'm going to rewrite them vertically and try to find a common denominator. So you ask yourself, what can 4 and 12 both become? So I look at the bigger number 12 and ask myself, can 4 become 12? Yes, it can. So then that's my common denominator. And if you couldn't think of that, remember, find the LCM. Oh, hey, 4 can go into both. 4 times what is 4? 1. 4 times what is 12? 3. You can't go anymore, so multiply all the numbers in the L for LCM along the outside, and you have 4 times 1 times 3. 4 times 1 is 4. 4 times 3 gives me that LCM of 12. So you can always fall back on this if you can't find the common denominator in your head. Okay, this guy is already a 12, so I can just keep that as 7 because it's like you multiplied it by 1 and 7 times 1 is 7. So I just kept this as 7/12. But this one, what did you multiply the 4 by to get this 12? You multiplied it by 3. So then multiply this guy by 3, and 3 times 3 is 9. Now, why did I do this? Because I needed to get it so that they both had the same denominator of 12, and then I could combine the numerators. And 9 and 7 make 16. And I could do this because 9/12 is equivalent to 3/4. I just rewrote 3/4 as an equivalent fraction by essentially multiplying by 1, because any number over itself is 1, right? So I didn't really change the value of 3/4. I just rewrote it with a different common denominator. The last thing you want to do is look to see if you can simplify, which we can't leave this improper. So I'm going to take the top number, 16, and divide it by the bottom of 12. How many times does 12 go into 16? Goes in once. And when you subtract that, you get a remainder of 4. So I put my remainder 4 over what I divided by, which was 12. And then always ask yourself if you can reduce it. You can reduce this guy by 4. So your final answer then is 1 1/3, because 16 over 12 is equivalent to 1 1/3. Remember that a fraction is literally saying the top number divided by the bottom number. Okay, if you didn't try that one by yourself first, at least try this one. So I have 18 3/4 minus 5 1/6. And I want to see, what can 4 and 6 both become? So the doing it in your head way, look at the bigger number 6. Can 4 become 6? No. Well, 6 times 2 is 12. Can 4 become 12? Yes, it can. And if you couldn't do that, again, LCM, well, what can go into 4 and 6? 2 can. And 2 times what is 4? 2. And 2 times what is 6? 3. And I can't keep going, so I'm going to multiply the L for LCM. You got 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. Okay. Now you have, let's recreate 1/6 as an equivalent fraction. So what did you do to the 6 to get this 12? I multiplied it by 2, which means I need to multiply the numerator by 2, and 1 times 2 is 2. Okay, what did you multiply the 4 by to get it to become 12? You multiplied it by 3. So do the same thing to that numerator, and 3 times 3 is 9. Okay, again, 9/12 is equivalent to 3/4 and 2/12 is equivalent to 1/6. Now that I have the same denominator of 12, let's combine those numerators and always pay attention to that sign. I'm subtracting 9 minus 2 is 7 and 18 minus 5 is 13. That can't reduce, it's not improper, so I'm done. Okay, hopefully you did pretty well. Let's take a look at the next one. It says you have 9.5 minus 5 3/4. Well, what can 2 and 4 both become? Look at the bigger number 4. Can 2 become 4? Yes, it can. This is already a 4, so let's keep that a 3. But what did you do to the 2 to get that to be a 4? You multiplied by 2. So do the same thing on top, and 1 times 2 is 2. Now the problem is that when you go to subtract these, you realize that you can't take 3 from 2. So I have to borrow from the whole number, so it becomes an 8 now, and I'm going to add 1 as a fraction of the same number over itself, right? Because like essentially normally like we add 1 to it, but when I add 1, I want it to be in a fraction form. So what number should I put to be over itself? Pick whatever that denominator is because we want the common denominator to be 4, right? And so now when I added 1, I added 4 over 4. If the denominator is 5, fine, then I'd add 5 over 5. If the denominator is 7, I'd add 7 over 7, etc. So I keep the denominator the same. Now I combine these new numerators. 2 and 4 make 6. Now you have a big enough numerator to take 3 away from. Well, 6 minus 3 is 3. Keep that denominator the same with 4. And don't forget those whole numbers. 8 minus 5 is 3. You can't reduce it, so you're done. That one was pretty tough. Okay, let's try the next one. It says that you have 12 minus 4 5/9. Now this looks easier than it is. The problem is that if it was like, let's say 12 5/9 minus 4, sure. 5/9 minus nothing is 5/9. And then you do 12 minus 4 is 8. But that's not the same thing as this. This is saying, can you take 5/9 from nothing? No. So I have to borrow from the whole number and then put something here. And that something is 1. So I'm going to write 1 as a fraction. What number do you think I should choose to put over itself? Hopefully you said 9 over 9. Why? Because I wanted them to have a common denominator of 9. And since I can write 1 as any number I want over itself, pick whatever that common denominator is. Now you have the numerators. 9 minus 5 is 4. 11 minus 4 is 7. That can't reduce, so you're done. If you got that one right, good job, my little mathematicians. You're doing great. Okay, so we're going to move on now from adding and subtracting, and now we're going to do multiplying and dividing. When you're multiplying, we can't just multiply the whole numbers. It doesn't work that way. So I got to change this to an improper fraction. So remember, you keep the denominator the same, and then you multiply these two, the denominator with the whole number, and you add the numerator. So 6 times 3 is 18, and 18 plus 5 is 23. When it's a whole number, to make it a fraction, you just put it over 1. So it's going to be times 12 over 1. Do I do keep, change, flip? No, we do not. That is only for dividing. When we're multiplying, we don't do that. But I can just multiply across 23 times 12 and then 6 times 1 and divide it. But what might make it easier is if I try to see if anything can cross cancel. Do you see anything that can cross cancel this way? No. How about this way though? Yeah, what can go into both 6 and 12? That's right, 6 can. What is 12 divided by 6? 2. And what's 6 divided by 6? 1. So now when you multiply across, on top you have 23 times 2 is 46, and on bottom 1 times 1 is 1. And 46 over 1 just simplifies to 46. So yes, you could multiply 23 times 12 on top and then 6 times 1, but then you would have gotten a big number divided by 6, and you would have gotten an answer 46. So cross-canceling just makes your numbers easier and smaller to deal with. So I highly recommend it if possible. Okay, this guy, we're going to change both of these to impropers. So that's a 4. This denominator is a 5. And to get your numerators, remember, it's this times this plus this. Well, 4 times 1 is 4, plus 3 is 7. This one, 2 times 5 is 10, plus 2 is 12. Okay, I can already jump straight into cross-canceling. And I can't cross-cancel these guys, but these ones, what can go into 4 and 12? That's right, 4 can. 12 divided by 4 is 3, and 4 divided by 4 is 1. When you multiply across, you have 7 times 3 is 21, and 1 times 5 is 5. The only problem is I can't leave it like that. That is a improper fraction. So I'm going to take the top and divide it by the bottom. How many times does 5 go into 21? That's right, 4 times, because 5 times 4 is 20. When you subtract that, you get a remainder of 1. So I'm going to put my remainder over what I divided by. And my final answer is 4 1/5. All right, my little mathematicians, we're moving right along. Let's go ahead and take a look at that second page. So we've done adding, subtracting, and multiplying. Now we're going to do dividing. And when we divide, it's the same kind of rules as multiplying. If there's mixed numbers, we got to change them to impropers. The only thing that's different is I can't actually divide. I can only multiply fractions, so I have to change it into a multiplication problem. So I'm going to keep the first fraction the same, change division to multiplication, and then flip that second fraction. Now it's just a multiplication problem like before. So these can't cross cancel, but these can by 5. 10 divided by 5 is 2, and 5 divided by 5 is 1. When you multiply across on top, 2 times 2 is 4, and on bottom, 1 times 7 is 7. It can't reduce, so I'm done. The next one, again, they're both already fractions, so just to keep, change, flip. And now, what do you see that can cross cancel here? Nothing can go into 3 and 5, but what about 12 and 16? That's right, 4 can. And what is 16 divided by 4? 4. And 12 divided by 4 is 3. So when you multiply across on the bottom, you have 3 times 3 is 9, and on top, 5 times 4 is 20. But that's improper, so I can't leave it like that. So I'm going to take the top and divide it by the bottom. How many times does 9 go into 20? That's right, 2 times, because 9 times 2 is 18. And when you subtract that, you get a remainder of 2. So I'm going to put my remainder over what I divided by. Okay, we're moving right along. If you haven't tried any yourself first, why don't you try these guys? Okay, when it's a whole number, remember you just put it over 1. Keep that the same. Change division to multiplication and flip that second fraction. Do you see anything that can go into 4 and 6? Yeah, 2 can. 4 divided by 2 is 2, and 6 divided by 2 is 3. When you multiply across, you get 3 times 7 is 21, and 1 times 2 is 2. Take the top and divide it by the bottom because it's currently improper, and 2 goes into 21 10 times. And when you subtract that, you get a remainder of 1, so you put your remainder over what you divided by. And so you got 10 and a half. Okay, last one of these types. Put that over 1, so that's 20 over 1, divided by, this guy is 7, 14 plus 2 is 16, but it's still a division problem. So I want to do keep, change, flip. Do you see anything that can cross cancel? Yeah, 4 can go into both of these. 20 divided by 4 is 5, and 16 divided by 4 is 4. When you multiply these across, you get 35 over 4. And improper, so I got to take the top, divide it by the bottom. 4 can't go into 3, but it goes into 35. You guessed it, 8 times, because 4 times 8 is 32. When you subtract that, you get a remainder of 3, so you put your remainder over what you divided by. Okay, last ones. When you want to find fractions that are equivalent to each other, what I recommend doing is reducing this guy all the way down and then seeing which other ones reduce to the same thing. So here, I see maybe 6 can go into these, and that's 4/12. And then I see 4 can go into those, and that's 1/3. So 1/3 is all the way reduced. So obviously that guy works. That's all the way reduced and it's not a third. That guy's all the way reduced and it's not a third. But these others, I want to see what they reduce down to. So here, what can go into 12 and 36? 12 can. What is 12 divided by 12? 1. What's 36 divided by 12? 3. 1/3 is equivalent to 1/3, so that guy works. What can go into 6 and 18? 6 can. And what's 6 divided by 6? 1. What's 18 divided by 6? 3. Can I reduce it anymore? Nope, and it's already a third. Okay, here, 3/9 can reduce by, you guessed it, 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. That guy's also a third. Here, I can reduce that guy by 2, and 2 divided by 2 is 1, and 6 divided by 2 is 3. So there's another third. Finally, the last one I have left is I see 12 can go into both of these, and 48 divided by 12 is 4, 144 divided by 12 is 12, and I could keep reducing it, but I can see right here that that was already like part of the one that I reduced it to up here, so obviously 4/12 is going to keep reducing to 1/3. So those guys are equivalent. Right, so hopefully, no matter how you did it, you guys could have used different numbers to reduce it down, but you should have ended with B, C, D, E, F, and H are all equivalent to 1/3, or 24/72. Okay, that one was pretty tough. If you did good on that, great job. Last one. When there's 3 numbers, okay, first off, rewrite them all as fractions. So this one, let's change this to an improper. So 10 times 2 is 20, plus 7 is 27. Already a fraction, already a fraction. It's up to you. You can cross cancel in any order you want of the 3 from top to bottom. So like you could do the 3 into the 27. Actually, that's all it works for that one. And then the 5 and the 10. So let's see. What can go into 3 and 27? That's right, 3 can. So 27 divided by 3 is 9, and 3 divided by 3 is 1. Okay, so those guys are all used up. Now you also have that 5 and 10. What do you see that can go into those? That's right, 5 can. So 5 divided by 5 is 1, and 10 divided by 5 is 2. So on top, let's see, you have a 9, 1, and 1. Well, 9 times 1 is 9. And on the bottom, you have 1, 8, and 2. Well, 2 times 8 is 16, times 1 is just 16. Can anything go into 9 and 16? Nope. So that's it. You're all done. If you got all of those right, congratulations. You're totally ready. You've mastered this. If you missed any, then go back and find similar types of problems, either Google multiplying fractions or dividing fractions, or go look back through our packet and retry some similar problems. All right, my little mathematicians, you're going to do great. You got this.